This experiment is dealing with Charles' law, which is volume 1 over temperature 1 equals volume 2 over temperature 2. It is saying that volume is directly proportional to temperature. So in this experiment we're going to take a crushed ping pong ball and we're going to drop it in boiling water. Since the temperature increases, based on the law, the volume will increase too. So the ping pong ball should return to its original shape. So here we have the crushed ping pong ball. I'm just going to drop it in the boiling water. As you can see, the volume of the ping pong ball increased and it is back to its original shape. Okay, so here we have the math portion of Charles' law. We start out with the formula of volume 1 over temperature 1 equals volume 2 over temperature 2. Our original temperature was 70 degrees Fahrenheit, so first we have to convert it to Celsius using math, and then we get 21.1 degrees Celsius. We add 273 and get 294.1 Kelvin. And then temperature 2 is 100 degrees Celsius from the boiling water, and you add 273 to that to get 373 Kelvin. The volume of the crushed ping pong ball was about 24 centimeters cubed, and so we set up the equation of 24 centimeters cubed over 294.1 Kelvin equals volume 2 over 373 Kelvin. Using math, we figure out that volume 2 equals 30.439 centimeters cubed, so the volume did increase when the temperature increased. This experiment is dealing with the Gay-Lussac's law, which is pressure 1 over temperature 1 equals pressure 2 over temperature 2. It's saying that pressure and temperature are directly proportional. And so in this experiment we're going to take a piece of newspaper and we're going to put it in the jar. Then we're going to light 2 matches and throw them into the jar too. We're going to place the egg on top of the jar, and the fire will go out because there's no more oxygen, and it will cause the pressure on the outside of the jar to be greater than the pressure on the inside. The egg will suck into the jar.
That's probably good. Once the fire catches.
Okay, so here we have the math portion of Gay-Lussac's law, which is pressure 1 over temperature 1 equals pressure 2 over temperature 2. Right here, the starting temperature was 90 degrees Celsius, so we had 273 to get 363 Kelvin. And temperature 2, which is room temperature, which we calculated earlier over here, is 294.1 Kelvin. The original pressure was about 950 millimeters of mercury, and so we put that over the original temperature, 363, equals pressure 2 over 294.1. And we calculate that the pressure 2 equals 769.683, so the pressure inside the bottle decreased when the temperature decreased, causing the egg to suck into the bottle. This last experiment is dealing with Boyle's law, which is pressure 1 times volume 1 equals pressure 2 times volume 2. It's saying that pressure and volume are inversely proportional, so if pressure goes up, then volume will go down, and vice versa. And so we have this marshmallow in a syringe, and we have 7 milliliters of it. And then we're going to increase the pressure, so the volume should go down, and it goes down to 5 milliliters. Yeah, that's Boyle's law. So here we have the math portion of Boyle's law, which is pressure 1 times volume 1 equals pressure 2 times volume 2. Pressure 1 was about 750 millimeters of mercury, and volume 1 was 7 milliliters, and volume 2 was 5 milliliters. And so we plug in those numbers into the formula and get 750 times 7 equals 5 times pressure 2, and we get that pressure 2 was 1,050 millimeters of mercury, and so the volume did decrease, so the pressure increased.